let's do some Mathity-Math. Before we get started, I have my pencil. I have my eraser because sometimes we make mistakes and that is okay. And today we'll be doing some graphing. So I also have a straight edge ruler so I can draw some nice beautiful lines and measure them if I need to measure them. Okay, this practice quiz is for my 9th graders. They are MYP 4 students. And this is our Unit 3 practice quiz. It's called Equality Models. What we're talking about here is solving linear equations and systems of linear equations, both algebraically and graphically. We're going to also talk about using equivalence transformations, right? And using all of this math to solve real-world problems. And with that said, here we go. Question number 1 says, solve the equation by identifying the equivalence transformation you use at each step. And I'm even so kind here, I'm telling you right now, it's going to either be the addition principle or the multiplication principle. All right, so here we go. Looking at this, our goal is to isolate x or solve for x. Okay, if we're isolating or solving for x, we need to first get this term by itself, and that means we need to take care of this term right here. So this is plus 4. The opposite operation of plus 4 is minus 4. And we do that to both sides, opposite operations, balancing equations. Okay, and that principle we use right there is actually called the addition principle. And you might be thinking, well, if I subtracted, why are we using the addition principle? And just remember, addition is nothing else than adding a negative. So that's why we don't call it the subtraction principle. We can just call it the addition principle. Okay. So after we can now rewrite this, and so the 3x has not been changed. Positive 4 and minus 4 make 0, so that goes away. And 19 minus 4 is, in fact, 15. Okay, so now we have this term by itself, and now we need to get x by itself. To get x by itself, this says 3 times x, or 3 multiplying x. So the opposite of multiplying is dividing. So we are going to do the opposite operation of dividing by 3. Okay, and that is actually called the multiplication principle. And again, it's not called the division principle because division is really just multiplying by a fraction or something less than 1. Okay, so that gives us x is 5, and there you go. Now, if you want to verify your work or check your work, justify your work, it's a good math habit. Maybe I'll just do a little section over here. Remember, when we check this type of work, we can just say the left-hand side must equal the right-hand side, okay? Left-hand side, right-hand side. And I'm saying where I see an x, I'm going to substitute a 5. So my left-hand side is actually going to be 3, and instead of x, I put in the 5. Plus 4, okay? And then my right-hand side is just 19. So this becomes 15 plus 4 is 19, and then you get 19 is 19, and that checks out. My left-hand side is my right-hand side, so good job. All right, moving on to question number 2. Same song and dance. This one, though, we start off with something a little different. It's actually not one of your principles, but it is a concept that we see a lot, something that we have talked about a lot. And that first step there of distributing that 3 to this part right here, this binomial here, and distributing your 4 to this binomial here, we just call that distribution. Okay, that's a good math term to know, especially because we're focusing on communicating our math knowledge and communicating using math language. So that's a good one to know. And here we go. So 3 times 3x is in fact 9x, and 3 times negative 1 is negative 3. And here we get 8x minus 12. All right, moving on. We now, again, we want to get all of the x's on one side and all of the numbers without x on the other side. So what we're going to do here is just a series of opposite operations, but at the same time. So long story short, the opposite operation of negative 3 is plus 3. I do it to one side, I must do it to the other side. That's called balancing equations. And I want to get this 8x off of the right side and represent it on the left side. So the opposite of plus 8x is minus 8x. And if I do it to one side, I must do it to the other side, okay? And all I did here was 2 bits of the addition principle. Okay, here we go. 9x minus 8x is just 1x. We call that x. These guys go away because negative 3 plus 3 is 0, so that's 0. Okay, equals 8x and negative x, again, 0. And negative 12 plus 3 is just negative 9. And there we go. Distribution, additional principle. And again, if you want to take it a step further and verify and justify, just same idea, left-hand side is the same as my right-hand side. And everywhere I see an x, I just substitute in a negative 9. So I'll write 3, instead of x, I say negative 9, minus 1 is 4, 2, negative 9, minus 3. Okie dokie. Let's just do some math. So order of operations tells us we go inside first. So I do this 3 times negative 9 first. So now we have 3 multiplied by negative 27 minus 1 is, and then we have 4 right here. This is going to be negative 18 minus 3. Let me make that a little bit clearer. Negative 18. Okay, there we go. Okay, so now again, before we don't fall into the trap of distributing, it's just a little bit of extra work. Let's actually do everything in the parentheses first. So I have a negative 27 and I go down one more. So now I'm at negative 28. And then here I have negative 18 minus 3. This is going to put me down to negative 21. Okay, and at this point, if you're not feeling terribly confident about your ability to do that mental math, no big deal. You can take out the old calculator and let's take a look here. So let me see if I can make this a little nicer for you. There we go. So right here, we're just going to say 3 times negative 28, and we get negative 84. I'll write that here. And this one I can do in my head. 4 times negative 21 is also negative 84. Ta-da! Left-hand side is right-hand side. Good job. All right, moving on. Let's keep it going to question number 3. Question number 3 says, 3 and 4. So here we go. Graph the following system of equations. Okay, step 1, graph the equations. Step 2 says, well, how many solutions do you see? Note, they are not asking for the solution. They just want to know how many you see. Okay, so here we go. This one right here is in slope-intercept form. So I know that I just go to here. This is my y-intercept. It is 3. So on y, I can just go to 3. Okay. And if you want to do a verification on that, just to make sure you're not doing something wild here, think about this. When I'm on the y-intercept, x is always 0. And if I put a 0 right here, this would multiply away, and it would say y is 3. So you see, my y, it is 3. Ta-da! Okay, my slope, my m value is 2 over 5. Let me just write that. It's a little bit bigger for you guys. It says m, my slope is 2 over 5. That's that bit right there, okay? And so this tells me to go over 5 and up 2. It's like your instructions. And you follow those instructions from your starting point, the first point you made. So here we go. I'm going to go over 5. 1, 2, 3, 4, 5. And then up 2. 1, 2. Voila. And now I have 2 points. And if you have 2 points, you can make a line. And here we go. Whee! I made a line. Okay, and so then my next one right here. Now this one is not in slope-intercept form, but this is a really easy way for us to just find the intercepts. So if you imagine this, if I want to find my y-intercept, my x value must be 0. So imagine this x is 0. 2 times 0 is 0, so that goes away. So now I have 2y is 18. Now, if 2y is 18, I can divide 2 from both sides. Here, I'll write it right here to be very clear. If I know 2y is 18, and I do my multiplication principle and divide both sides by 2. When x is 0, I know that y is 9. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, right here. Ta-da! And you can do the exact same idea, and all the numbers are the same here. So if I want to find my x-intercept, I know my y value is 0. So if this y value was 0, I'll just cover it with my pencil here, right? You'd have 2x is 18. You divide that 2, and you know that when y is 0, x is 9. And that's right there. So now, all you gotta do is draw your other line. And that's perfect for me. Okay, and now this goes into a big conceptual idea that we really need to have locked in. It says, how many solutions are there to the system of equations? So, and this is the big idea we need you guys to have, is that when you have a system of equations, where they intercept or where they cross is where the solution is. So you can see these only cross one time, so they can only have one solution. So the answer here is there is one solution, because they only touch or cross at one spot. It doesn't ask you to find that spot. We'll do that later. So we know there is just one solution. Okay, doing great. Moving on. Question 5 and 6, exact same idea, just 2 different lines. Now this one says, y is x. Okay, so they're saying whatever you put in for y, you get the same for x. So if y is 0, x is 0, done. If y is 1, x is 1, done. If y is 2, x is 2, done. If y is 3, you get the point, right? So essentially, it just goes like this. There's one line. Now this one is in slope-intercept form, y equals mx plus b, or plus c, depending on how you learned it. Okay, so this next one, it says y is x plus 3. So this again is in y equals mx plus b, or c, I guess, depending on where you learned it, but slope-intercept form. So again, you first things first, go to your y-intercept. This is the value where the line crosses y. So it says 3, so I go to 3, and this line will cross at 3. And my slope m is right here. Now you can see on this x, there's actually nothing there, but there's a 1 there. And so in this case, you could say, well, m is 1, or you could think of it as 1 over 1. So it's saying go over 1 and up 1. Okay, so I'm at 3, and I go over 1, up 1, over 1, up 1, over 1, up 1, and there you go. You can see you have a bunch of points. Now all we have to do is make sure our line goes through them all. And here you go. Now here's another very big concept. Because equation A has a slope of 1 and equation B has a slope of 1, they have the same slope. And when lines have the same slope, they are parallel. And parallel lines never touch and they never cross. So again, with the same understanding, the solutions are found to systems of equations where lines cross. Because these never cross, they don't actually have a solution. So you would just say, no solution, right? And that's just building off that idea that solutions occur where the equations cross. These didn't cross, no solution. Moving on. Last one of this type, question 7 and 8, same instructions, same idea. All we need to do is graph these lines and see what's going on. Okay, so the first line, our y-intercept is 5, so I go to 5. 1, 2, 3, 4, 5. Here we are, okay, right there. And now here's my slope. My slope is -1. So here, again, thinking like this, if my slope is -1, I could also think of this as like saying it's -1 over 1. And you can put this negative sign either way. So you could either go over 1, down 1, or you can go back 1, up 1. So because we're already right here, I'm just gonna go over 1 and down 1. So to be really clear, I'm going over 1, that's the positive piece, and down 1. And that's what that negative is doing. So I guess maybe if I wanted to make that super clear, let's look at this. I'll just let that negative sign live right there. And that's okay. All right. So again, over 1, down 1. Over 1, down 1. Okay, that's enough. 4 points. I mean, honestly, you only need 2 points, but just to make sure I'm doing a good job. There you go. I did all of them. So there's my line. Now, looking at this one is really set up nicely to find my intercepts. So if x is 0, okay, I can find my y-intercept just by dividing both sides by 2. 10 divided by 2 is 5, so it's actually here. Doop. Same one. Oh, it shared it. Okay. And if I make my find my x-intercept, I can just make y 0, so that it would multiply away. And I would see if I divide both sides by 2. My x-intercept is also 5. Let's see here. 1, 2, 3, 4, 5. Would you look at that? It's actually the same line. So again, when you think about the concept of solutions are found where systems of equations or where lines cross, these lines are sitting on top of each other. So they're touching here and 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 here, here. They're touching everywhere. So how many solutions does it have? Well, it actually has infinite solutions. Everything would work. And that is that. Moving on. All right, we are getting into the real world application part. All right, so here we go. It says, Mr. Sando collects Pokemon cards. In January, Mr. Sando went to the mall to buy 8 booster packs, okay? 8 booster packs of Pokemon cards, and then 6 pre-made decks of Pokemon cards, for a total of 372 cards. So if we just wrote that piece of the puzzle down right there, it's saying Mr. Sando went and bought 8, what's it called? Booster packs. 8 booster packs. And then I also bought 6 pre-made decks, and that together had 372 cards in it. All right, the next part of the story. This month, Mr. Sando bought 8 more booster packs of Pokemon cards and 9 pre-made decks of Pokemon cards for a total of 510 cards. So here we go. I had 8 booster packs, and then I also bought 9 pre-made decks, and that gave me 510. Okay, there we go. So at this point now I have my 2 equations, and what I can do here is I need to get rid of one variable, and this one's set up quite nice to just use elimination. So what I'm going to do is just subtract this equation from the other equation, or vice versa. Subtract this equation from that one. It's going to look like this. So if you think about it, 8b minus 8b is 0. It's gone. There's one variable gone. Now we can just solve for p. And 6p minus 9p would give me negative 3p. And that is going to equal, now 372 minus 510. And if you don't know this, you can just bust out your calculator. But it is negative 138. And now you can see how all of this math layers onto itself. Because to isolate p, I now need to do the multiplication principle and divide both sides by negative 3. And now I have p isolated, and I would find that p, and again, you're more than welcome to use your calculator, a negative by a negative is positive, so I get positive 46. Right, and that's a good indication it's positive because there's no such thing as negative cards, so your answer definitely should be positive. Okay, now because I have p, what I can do now is go back to one of my original equations and substitute p in and isolate to find b. So I'll just do that right over here. So basically what it's going to look like is, I said earlier we had 8b, I'm just copying this equation right here, plus 6, and instead of p, I say 46, and that equals 372. All right, so now we just kind of do some math, and we're going to get 8b we distribute, or we multiply those together to get 276. And you again, use that calculator, is 372. We use the addition principle to subtract 276 from both sides. So I'll just write that there. Okay. And you get 8b is, and if you subtract that from both sides, you get 96. And then you use the multiplication principle to divide 8 from both sides, and you're going to find that b is 12. Now, at this point, for further clarification, justification, if you want, you could also substitute p into your second equation and make sure you get the same answer. Furthermore, you could also check these all by substituting in both values and doing a left-hand, right-hand check like we did earlier, okay? I'm not gonna do that now, but I encourage you guys to try it and verify. It's a really good skill to have. So now it says here, to draw a sketch of the story to justify your answers, okay? So what I want, and I should have clarified these instructions, what I actually want you guys to do is to make a graph, a quick sketch of a graph to justify these answers, all right? I'm going to talk about this, and it might take a little bit doing. I might fast forward to the drawing part, but it'll make sense in a second. Give me one. Okay, so I'm going to fast forward through a lot of this just to draw my graph, but I want to talk to you quickly about my thought process of helping set up my graph here. And this is my thought process. So I have like equation A. And in here for this, instead of B, I'll write X, and instead of P, I'll write Y, just because we use Y and X's when we make this graph. But if my first equation looks like this, right? I'm gonna take a second here and just try to find my x-intercept and my y-intercept, okay? So my x-intercept and my y-intercept. And the reason I'm doing this is I'm trying to think of like the size of my graph, and this will kind of help me here. So again, remember when I find my x-intercept, I make y 0, right? So my x-intercept is gonna be 372 divided by 8, okay? And I've already done the math on my calculator. 372 divided by 8 is 46.5. So on my first equation, I know it's going to be 46.5 is my x-intercept, and then y is 0. And the same idea, I make x 0, so that would go there, and I divide 372 by 6, and I would find that my y-intercept is 62. And I'm doing this to just try to think about the size and the scale of the sketch I need to make. This will just kind of tell me where to start and stop, so I'm not drawing giant graphs or graphs that are too small and I can't use anyway. Let me draw a line here just to keep this like my little work area. Okay, and then for the equation B, again, I'm just going to say 8x instead of the b, 8x plus 9y is 510. And so my x-intercept and my y-intercept. So to find the x-intercept, I plug in a 0 for y. To find the y-intercept, I plug in a 0 for x. Okay, and let's go ahead and do this. So again, if I make, for my x-intercept, I make y 0. I cover that up. That's going to go away. So essentially, it's 510 divided by 8, okay? And 510 divided by 8 is 63.75. And I did not do that in my head. I just already calculated earlier and wrote it down, okay? And then for the y-intercept, I make x 0, so it's 510 divided by 9, and that's going to be 56.6. Actually, 56 2/3. Okay, so again, this is really just to help me make my sketch and see how far my x should go and how high my y should go. So my x, this one goes to 46, this one goes to 63. So I'm gonna make my x go to 65. That's my idea here. I'm gonna make it go to 65. So now, okay, so let me just reiterate that. I'm gonna make my x go up to 65 and my y, so this one goes to 62. Okay, so 62. So I'm gonna make my x 65 and I'm gonna make my y 65. All right, this next part's gonna go really, really fast, because I don't need you guys to watch me draw in real time. But anyway, get ready. Okay, so this is like the foundation of my sketch, and you can see I probably should have flipped my paper over and did it on this beautiful blank space, but this is where we are, and this is what we're gonna work with. Now, I have some of my work here from earlier. I'm gonna erase this for the sake of this video. Obviously, this is not what I'd want you to do on your quiz. And don't you worry, on your quiz, I will give you guys way more space. Maybe I'll make giant pieces of paper. Who knows? But anywho, this is just for this video. Please don't do that on your test. All right, here we go. So equation A, we found out that our x-intercept is 46.5. So that would be like right, this is 40, 50, that's 45. So it'd be right about there, okay? And then my y-intercept was 62. So here's 60, so, and this is 65. So 1, 2, 3, 4, 5, be about right here. Okay, so there we go. So I can nicely, here, just by using those intercepts, make a pretty good looking line here. And I'm gonna put an A, because that's equation A. Okay, and then for equation B, we said my x-intercept is 63.45. So that would be, let's see, 1, 2, 3, 4, 5, about here. Okay, and my y-intercept was 56.6. So 50, let me just, I used a centimeter for 5. There we go. So 56 would be like right here. Okay, second line, here we go. Just the piece I erased earlier, I said B is 12. Okay, so the idea here is if we look at this, so B is our X and P is our Y. So we're doing kind of like a sanity checker to make sure everything is on the up and up. So this one, if this is right here, so let's see, 10, 11, 12, 13, 14, 15. So I'm a little off, but you can see my X is pretty close to 12. And then for my Y, should be pretty close to 46, which would be about here. So you can see I'm in the general vicinity, and that's just how a sketch can kind of help you see that, okay, it all lines up. It does kind of double check itself or verify itself. And that's why we want to make these sketches, okay? Just to make sure that, you know, everything is kind of making sense. So my answers were 46 and 12, and my graph shows we're in the range of 46 and 12. So this is that I think my work is good. And you can triple justify that by doing left-hand, right-hand side and checking your algebra. Okay, there we go. Move question 11, 12, and 13. Okay, so question 11 says, just solve this inequality algebraically. Okay, so what we do here, guys, is we just use the exact same math or algebra we'd use if there was an equal sign. So right here I have a 4, so the opposite operation of a 4 is a -4, so that is the addition principle. I'm gonna rewrite, so I get -2x is less than or equal to -2. And again, here we go, I just need to get x by itself, so I just divide both sides by -2. And here we gotta be careful, because remember, when you multiply or divide across an inequality, the sign changes, okay? So here, -2, so that's just gonna be x. The sign changes because we divided by a negative. And -2 divided by -2 is 1. And so what this says here is all x values that are greater than or equal to 1 are valid x values, okay? And then they say, well, show this graphically or solve this graphically. Basically, this is pretty fast. You just make your x, make your y, label it, okay? And then on x, I'm gonna use all values that are greater than or equal to 1. So this is 1, right? I'll just put a 2 here just to give a little context. Okay, so my line is gonna go right here, and that line is gonna be a solid line because it is also equal to, comes all the way down. And then all I do is nicely shade that. And that shows all the x values from 1 all the way to positive infinity would be good solutions to make this true. If you wanted to verify that, just pick an answer. And this is kind of interesting. We'll pick an answer on the true side and the not true side. So let's say I picked 10. If I substitute in a 10, I would say 4 minus 2 times 10 is less than or equal to 2. And let's check the math. 4 minus 20 is less than or equal to 2. 4 minus 20 is negative 16 is less than 2. Is that true? That is true. Negative 16 is in fact smaller than negative, oh, that's not supposed to be negative, oopsie. Smaller than 2. That's true, okay? So we verified that this makes sense. And just to kind of show you what happens when it's not right, let's say I went over here and I chose the point negative 10. And so I do the same idea. I write 4 minus 2 times negative 10 is less than or equal to 2. Okay, and let's check this math. So we have 4 minus, and so 2 times negative 10 is negative 20 is less than or equal to 2. Okay, now you can do this lots of different ways. I like to imagine that this is distributing here. So a negative times a negative makes a positive. So now I have 4 plus 20 is less than or equal to 2. And now the statement says 24 is less than or equal to 2. Is 24 less than 2? No, it's obviously bigger than. So you can see that that is not a valid solution, and that's why the solutions on this side don't work, because they make untrue statements, okay? Just another layer of verification and justification, something you can totally do on your test to bump up your display of knowledge. All right, last one. It says write this in set notation. Okay, so set notation is basically saying you write this first. It says I have a set of numbers, okay? What are the set of numbers we're talking about? Well, we're talking about x, okay? We're talking about x. We're talking about x such that we all agree, or we all know that x is a part of the real numbers, not imaginary, and x is greater than or equal to 1. That is your set. That is your set notation, okay? Once again, you say, all you read this as is the set of all x's such that x is a real number and x is bigger than or equal to 1. And there you go. That is set notation. Moving on. Here we go. Question 14. We are graphing inequalities, okay? And it says, show clearly the region that satisfies the system of equations. Okay, so for this part right here, first things first, we have this piece right here talking about the x's. And we call that the domain, but we haven't learned about that yet. But the x values, or the domain that are acceptable or okay. Now, what I like to do here is kind of break this into two pieces to help me really clearly see it. So it says x must be greater than 0. I'm gonna write that right here. X must be greater than 0. Okie dokie. X must also be less than 4. So those are two inequalities wrapped up in one. And y must be less than or equal to 2. Okay, let's draw this and show what we know. Again, real quick, I'm just going to draw myself a nice Cartesian plane or a coordinate plane, just a little sketch. We're not measuring, we're just trying to visually show what this all means. Okay, there's my x's and my y's. So first things first, it says x must be bigger than 0. So these are my x values. So it's saying x must be bigger than 0. We have to draw a line on a line here. But now this one, you can see it does not have the equal to sign. So you have to use a dashed line. And this can be kind of tough to clearly show. So I always extend it like beyond the y-axis to be really clear. And I'll even be extra clear here. I'll say, all right, x is greater than 0 to show that I'm drawing a dashy line here. It can be hard to see, I get that. Okay, the next one says x is smaller than 4. So we have 1, 2, 3, 4, okay? And again, it's going to be a dashed line because there's no line underneath, no equal to sign. So I'm drawing my dashed line. And if this were just the problem, we would be able to say, well, okay, I can clearly see that the x values that are okay are in between these two lines, bigger than 0, smaller than 4. And so if this was just the problem, this would be the answer. But there's actually one more restriction on our range or our y values. And it says it must be smaller than or equal to 2. So we do a 1 and we do a 2. And so this one has a line, so we can make it a solid line. And so this would say y is less than or equal to 2. And so that's saying that it's actually everything below here. So this stuff up here is no longer a-okay. So what we're going to do here is I'm going to go the other way and really clearly show that this, oh man, when I say clearly, I'm not, there we go, that's better. Really clearly show that this is the area we're talking about, right? And you know, honestly, I thought this would look nicer, but I'm doing my best. Okay, there we go. It's there. There you can see. It clearly shows this is the area that's A-okay. All right, this area right here. And actually, that's that. We are all done. Question 15. All right, another big time real world question here. And this one is a little tricky. You got to kind of think it through, but here we go. You have a shoe manufacturer, a shoemaker. They make mid-top and high-top athletic shoes. Okay, so we have mid-tops and high-tops. Great. It says the cutting machines cut the fabric for the shoes. Stitching machines stitch the fabric. Okay, so we have cutting machines and stitching machines. Okay, the cutting machine runs 4 hours per day, and the stitching machine runs 5 hours per day. Okay, and so we have the mid-top shoe takes 1 minute to cut, so we have some time, and 2 minutes to stitch. And the mid-top shoe takes 3 minutes to cut and 2 minutes to stitch. So, and this is kind of how we have to think about it. When we think about this question, we have shoes, we have cutting, we have stitching, and we have time, okay? And this last part, this is the profit, and we can use this last to figure out how much we all could have made, okay? So if you want to think this through, think about how to express the ideas in certain different ways. So how about we just focus on what we know about cutting, okay? Okay, so if I just think about cutting, it told me that, oh, here we go, cutting right here. The mid-top shoe takes 1 minute to cut. So 1 mid-top shoe, 1 minute. 2 mid-top shoes, 2 minutes. 3 mid-top shoes, 3 minutes. So basically, it's 1 minute per mid-top shoe. M is for mid-top shoe, okay? And in the same idea of cutting, we also know that the high-top shoe takes 3 minutes to cut. So 3 minutes for every high-top shoe. And now you can kind of think about this. If you replace this variable with the number of shoes, you would get the number of minutes, right? If I did 3 high-top shoes, I know it's 9 minutes because 3 times 9. So this is the cutting of the mid-tops. This is the cutting of the high-tops. And then the next question is, was there any other cutting information? And it says it right here. Your cutting machine runs 4 hours per day. Now we're gonna be careful here. This is minutes, this is minutes, this is hours. So instead of hours, I'm gonna write 240. 4 times 60. So now it's all in minutes. And it says, so if you think about it, your cutting machine, this is how long your machine can run. These are the products, or this is what the machine is gonna make. So all of this time right here can never be bigger than 240 minutes because the machine doesn't run that long. So conceptually, if you say, well, if I took all my mid-top shoes cutting times and I added it to all my high-top shoe cutting times, whatever that adds up together, it must be less than or equal to 240 minutes because after 240 minutes, the machine cuts off. So that's your cutting equation, all right? Now we also have stitching. Now when we look at stitching, we're also stitching our mid-top shoes. We're also stitching our high-top shoes. To stitch your mid-top shoes, it takes 2 minutes per shoe. 2 minutes per mid-top shoe. And to do my high-top shoes, it takes 2 minutes to stitch the high-top shoes. Okay, and then it tells you that the stitching machine runs 5 hours per day, which is 300 minutes. So again, if I take all the stitching for my mid-top shoes and all the stitching for my high-top shoes, however long that takes, all that time must be less than or equal to 300 minutes. And actually, this is a real positive sign when you look at this, because you've just set up 2 equations with the same variables. And so now you're in a position to solve these systems of equations. Now, if you wanted to solve by graphing, you just have to make one of these x and one of these y, and you could pursue it that way. But this is also set up pretty nice for us to solve by elimination. And I'm going to do that work down here because there's one extra step we should take a look at. And that step I can talk about now. If you see here, none of these line up none of these line up perfectly nice. But if you think about it, I could multiply this by 2, and then I'd have 2m and 2m, and then they could eliminate nicely. Just remember, if I multiply this by 2, I also must multiply this by 2, and I also must multiply this by 2. So I'm going to do that right here, okay? So 1 times 2, I get 2m. This is my cutting equation, but I'm just multiplying everything by 2. 3 times 2 would be 6h, and this would be 480. Okay? And also, you know, when you solve these, you can, when we're just solving these to look for the solutions, you could leave it if you want. I just do this to. So now I'm going to bring down my stitching equation. Okay. And again, I'm just solving them as equations to prevent any confusion with these symbols, okay? We're okay. So now I subtract. 0, we get 4h. And so we're thinking about this as a point of intersection, right? The point of intersection. So when we divide 4 from both sides using the multiplication principle, we know that one of the points of intersection is 45, okay? So that gives us the maximum number of high tops, okay? Now, we need to plug this back into here, and that will allow us to find the number of mid-tops. So I'm just going to go to my first one right here. I'm going to say 1m plus 3. Instead of h, I put in a 45. Okay, and again, I'm just solving for a point, so I'm going to take out the inequality part just to keep this straightforward. If we multiply this out, m plus 135 is 240. We use our addition principle and subtract from both sides, and you're going to get m is 105. So you know it's 45 high tops and 105 mid tops. Now again, I encourage you, plug these back in. Do they make sense? Does it give you good answers? Is it less than 240? Will it let it be less than 300? These are the ideas of justification. These are the ideas of verification. Again, you can also make a graph if you wanted to. I encourage you guys, if you have the time, to take the time to show your different levels of knowledge and communicate that knowledge. And then finally, it says to find the maximum profit possible. Okay, so you just need to know that for mid-top shoes, you get $13. I'm sorry, I pointed up here. For mid-top shoes, you get $13. So 105 times 13, let's just do this right here. 105 times 13, 105 times 13. So the mid-top shoes would make you, okay. So the mid-top shoes make you $1,365. And then, so the high-top shoes, you get $16 per pair. So 16 times 45, Those make you $720. And if you add that all up, you would make $2,085. Boom, there you go. Last question coming up next. All right, we are in the home stretch. Last question of the practice quiz. Here we go. Says here, a factory manager has to decide which machines to install to manufacture a product. Okay, machine A, the output, that's what it makes. The output is 300 units per week. It needs 500 square meters of space, and it takes 10 operators, or you need 10 people to operate it. Machine B, the output is 200 units per week, and this one needs 600 square meters of space, and it takes 6 operators. Okay. The factory has a total of 550 square meters of space available, and it has 80 operators. Its production target, or it wants to make total 2,400 units per week. So it says determine if the factory can meet its production target, and then if it can, determine how many of each type of machine it should buy. Okay. So I'm gonna add a different piece of paper here because I know I'm gonna have to graph this and I know I don't have enough room. So I'm gonna write some ideas here and then move on. So the big ideas here, for each machine, we're talking about space and operators. So the first thing I'm gonna write is space. So space. So I have machine A, and I have machine B. Now, every machine A needs 500 square meters of space. So that's that. And you could imagine one machine, 500, two machines, 1,000, so on and so forth, okay? Machine B needs 600 meters. Okay. And it says the factory actually only has 550 square meters of space. Oops. Sorry about that. Okay, so again, if you think about this conceptually, they're saying all the space needed for A and all the space needed for B must be less than or the same as the amount of space available. So that's our space equation. Okay, now we have the operators. Same idea, machine A and machine B. Okay, let's do this here. And for the operators, well, machine A takes 10 operators. And again, think about this. One machine, 10 operators. Two machine, 20. Three machines, 30. That's how this works. And machine B, only 6. We add those together, and all of the operators, right, must be less than or equal to the 80 available. There's only 80 people working there. So you can't have more machines without enough people to work them. So these are our two. Okay, and there was a third piece of this puzzle, and that was the output. So I can write, let's see, output right here. We have A and we have B. Okay, so the output of A was 300. Oh, that's too close. Well, maybe not. And the output of B was 200. Sorry about that. A, B. And again, our goal, our output, where was that? Our output, right here. They want 2,400. So we know that whatever all the A machines do and all the B machines do, it cannot be less than what we want. So it can be bigger than that or equal to our goal of 2,400. Okay. There we go. So I got these three things. I'm actually gonna do a graph of feasible area, okay? So to make this graph, again, I'm gonna make my X and Y axis here. I do want to kind of do a, ooh, not the best job there. Okay. Okay, so there, I made my Y axis, And there we go. And so I made my y-axis, and what I did here, guys, I just, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So anyway, the idea here is I did all this, and I just marked every one at a centimeter. This is just so I know I'm not being too out of scale. And I just marked every halfway point just to help me, if I need something on a 5 or a 6, I can be close, okay? I'm gonna do the same thing on the X. I'm gonna, again, fast forward through all this, but here we go. Okay, so that should get us moving in the right direction. Now, for the sake of this, we'll make the A's X and the B's Y, and that'll help us make this graph. And so what I like to do, again, this is what we talked about before, is I like to find the X and Y intercepts, and that'll help me graph my lines kind of quickly. So I'll call this one equation A, B, and C. A, B, and C. Okay. I am going to make all the A's X and the B's Y. I'm going to change it all through the amazing process of movie magic. So here we go. A's will become X's. Wow! And then again, more movie magic. The B's will become Y's. Wow! Okay. So what I'm going to do here is, again, just make X zeros and Y zero to find the X and Y intercepts. So for line A, my X intercept is going to be when Y is 0. So all I got to do here is imagine that goes away because Y is 0. Use the multiplication principle, divide both sides by 500. So 50/50 divided by 500. And my X intercept is 10. So we'll call it about 10.1. Great. My Y intercept, again, is where X is 0. So again, I just divide 50/50 by 600. Boom, and I get about 8.42. That's okay. Again, this graph is just to get us close. Okay, so there is my equation with, my equation A, X intercept and Y intercept. So I'll just do that now. So this is right after 10. So coming down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's right there. Okay? And then my y-intercept, 8.42, 1, 2, 3, 4, 5, 6, 7, 8. So just under a half. Okay. So I'm going to go ahead and draw equation A. Okay. La-da. All right. For equation B, my x-intercept, let's see here. So well, that's straightforward. It's going to be 8. And my y-intercept, 80 divided by 6, 13.3. So about 13.3. Okay, I'll quickly draw equation B. Let's see here. Oh, actually, you know what? Real quick before we do that, if you think about this, it said this whole equation less than or equal to 50/50. If you want to check which side of this one it's going to be, just put in like 0, 0, right? Because that's super duper easy. So I put in a 0 and I put in a 0. It says 0 is less than 50/50. Well, that's true. So for this line right here, I'm going to do this very lightly so I don't make it too... This area so far is our acceptable area, our feasible region. But we're going to have 2 other lines, so we're going to have to work that out. Okay, so here we go. This one, the x-intercept is 8. That's right here. And the y-intercept is 13.3. So, right about there. Okay. All right, that is B. Again, so this one says is less than. Just to double check, put in 2 zeros. Is 0 less than 80? It is. So now it's everything below B that is also below A. So this part's not in, but this part's in. So now we have like this much. We're kind of building that feasible region. Okay, and now we're going to see what happens when we put in our third equation. So again, for equation C, my x-intercept, let's see here. So y is 0, it's 2400 divided by 300. I think we should know that one, it's 8. So my x-intercept is 8, and my y-intercept, is going to be 12. So here we go. X-intercept is 8. We already have that right here. Ta-da! A shared point. That's a good clue. And 12. Here we go. Now this one we're going to be really mindful of, because watch what happens here. Let's see. Now for C, I wonder if I should zoom in. Well, let's see what happens here. So for C, if I put in 0, 0, it says 0 is bigger than 2400. That's not true. So this side of C is not the side. It's actually above C. Now let me just zoom in here. So it's above C. This is my C area. So actually, your feasible region is this little slice right here. Let me see if I can really highlight that. That, and that. Okay, so basically what this is saying is, remember, solutions are where our lines cross, our equations cross, but we have a lot of possible solutions inside this area, and we're going to focus on the vertices here to try to find the best solutions, to optimize our solutions. Now, looking at this, I'll call this, where it is ABC. Okay, this is intersection E, F, and G. Okay, so one possible solution, so E is where A and C cross. All right, now I gotta zoom back out. All right, hold on. Okay, so one possible solution is where A and C cross. So one possible solution is 500x plus 600y less than or equal to 50/50, and 300x plus 200y greater than or equal to 2400. So this is the intersection that we labeled E. If we did this math and found those points of intersection, that might be one possible one. F, if you did F, it would be F right here. This is where B and A cross. So that would be A and B. So it could be this. Okay, that's another possible solution. And the last possible solution is actually down here at G. And we actually don't have to do anything for G. G is 8, 0, which represents 8 machine A's and no machine B's, okay? So what we would do with this information is you would, let me do this. You would solve these linear equations using elimination. And if you solve these using elimination, you would get, for this one, your x would be 5, we'll round 5.4, and your y would be 3.9. Now, obviously, you can't have 5.4 machines or 3.9 machines, but you could do a quick check for validity here. And this is how we really show our knowledge. I could say, well, what if I tested 5 machines on the X? So 1, 2, 3, 4, 5, I'm here, and 4 machines on the Y. And if you did that, you would actually see that that point is outside the feasible region. So this is actually not gonna work, okay? Because if you made it to the closest whole machine, 5 and 4, it's outside the feasible region. So that's not it, not gonna work. If you used elimination for F, and let's see here, if you did elimination for F, and you can do that, we did those types of problems earlier, what you would find is 5.9 and 3.5. And so again, you could look at this and say, well, what if I tried 6 machines and either 3 machines or 4 machines? And let's see. So 1, 2, 3, 4, 5, 6 and 4, or so actually 6 and 3 looks like it would be right here. So that could be one test you could do. You could test 6 and 3 because it seems to be clearly in your feasible region, or right on your feasible region. So this is one that we could also test, okay? And then 8 and 0, we know it's okay, and we could test that too. So what we're gonna do here is now we have a 6 and a 3, and an 8 and a 0. And you're gonna go back to your original question, and just plug these values in, space, operators, output, and just kind of make sure it all works, okay? So, and this is pretty fast. So if I take 6 and 3, and go look at space and output. So 500 times 6 is 3,000. 600 times 3 is 1,800, so we had the 3,000. Okay, it's under. Yay, it works. If you checked your operators, you would have 60 plus 18. So just to prove that, 60 plus 18, 78. Okay, you are good for operators. So there is enough space, there are enough operators. And so now we gotta find which one gives us the best and most output. Okay, so you plug in the 6, you get 1,800, and you plug in the 3, and you get 600. So 1,800 plus 600, and you're gonna find out, oh, my output is my goal. So 6 and 3 totally works. Yay! Now let's check 8 and 0. Now this one's saying we're not even gonna use this machine. So check it out, 500 times 8. It's under, we have enough space, woohoo! If we check our operators, 10 times 8 is 80. We have enough operators, woohoo! And if you check the output, 300 times 8, the output is 2,400. So they both meet the goal of an output of 2,400, and they are both in your feasible area. Now, this is where you can really show your knowledge, and I encourage you to think about this. Do you choose 6 big and 3 small, or do you choose 8 big and no small? And you can think about space. You can think about operators. Output doesn't matter. Output doesn't matter because they're the same. And you can also think of other real life ideas. Now, I encourage you to, if you look at this and you're like, I think this or I think that, put it in the comments below. Let's share our answers. Let's share our knowledge. Maybe get a good discussion going about why we should choose this option or why we should choose that option. I really do encourage you guys to take the time to put a comment down there, and let's start a vibrant discussion. All right, guys, that's it. Boom, we did it. Be safe, make good choices. You guys are gonna do great. Bye.